Hi, welcome back to our Kotlin series. We're learning how to use the language of Kotlin so that we can eventually become mobile application developers with Android. So building our skills in Kotlin will help us out later. My name is Shad Sluter and I teach software development at Grand Canyon University. So if you'd like to learn how to become a programmer and you want to join us in class, essentially you can come here on YouTube as well as on my channel where you can get all the source code from these videos. So let's take a look at our task before us. What we're trying to do in this video is show the precision of a float versus that of a double. So they both do decimal numbers, but why would you pick one over the other? Okay, so let's start with some code that would look familiar if you were on the previous video. So what we're trying to do is get some information from the user. So that's called readline. And you can see that that comes in the form of a string. And then we're going to do a conversion. So we're going to take that string, convert it to a double, and save it. The try and catch area is going to help us catch errors. And then finally, we're going to print the results. So this is where we were at the last video. So if I were to run it again, type in a number like 44.2, and it comes off with a 44.2 for an answer. So far so good. Now, what happens if I do a division problem with that? So let's put in another statement that says, here's the number that you have, and it's divided by 9. So inside of the little curly brackets here, we can do a calculation. So the $sign says, give me the value, and the curly brackets allow us to combine things, such as divide by 9. Let's see what it looks like when I divide a number 9 in mine. Let's pick an easy one. So I'm going to take 6. What is 6 divided by 9? Quick. It's 2/3, right? And 2/3 as a decimal comes out like this. It's a 6 repeating, so 6, 6, 6, 6, 6. And notice it has a lot of different decimal points. So the precision on this thing is very high. That's out into the trillionth places or something like that. Really big. Now what I want to show you is the difference between this and a float. So let's copy all of the code that we just did, and I'm going to duplicate it. So I'm going to paste it. And now I'm going to say save an input. We don't need to redeclare it. And instead of double input, I'm going to call it a float input and change this to a float variable type. So it's still a decimal, and it's going to now be saved as a less precise item. So let's say I'm going to change that to a float. So everything's the same almost, except for the data type. Okay, so here is our float input. I'm changing all of these, and that's also float input. Okay, so quick to review what I just did. I said, give me a float input, and we got an error. It says 0.0 doesn't work. What you do instead is a capital F instead of a decimal. And so that says this is a float. So a 0F means 0.0. Okay, float, and then the rest of it's all the same. Okay, let's see what this does. First of all, it's going to ask me for the double. So let's put in a 6. And then it says, give me another answer. So 6. And right away, you should see a difference. Do you see it? Same code with one exception or one change. And we changed the number of the data type from a double to a float. So what is the precision value on this number here? Well, it's a lot less than this one up here. So what's the deal? Well, in a computer system, inside in the memory, all that precision takes extra space. So a longer number means that there are more bytes taken up, more memory, more RAM, more storage on your disk. And so in certain occasions, you can use a float to save space. You might think that the speed at which the computer works is also different. So it might be that floats are a little bit faster than doubles. So if you're doing financial computations, you probably want the most precise thing that you could do. So if you had to compare between a float and a double, which one's more precise? Double. Double is the answer I'm looking for, right? Yeah. So double's more precise, so use that for your high precise work. So in summary, what you learned was that floats and doubles are both decimals, and the float is less precise than the double. Both of them can be used to do decimal math. In the next video, I'm going to show you a few functions in a library called math, and we'll use things that will help us calculate geometric things like the letter pi or other type of reserved keywords. So stick with me and you'll continue to learn the Kotlin language. We'll see you in the next video.